viewers, my name is Akiomi Olumayowa. I will be teaching a very important topic in physics, which is titled Reflection of Light Through Plane Surfaces. Light is a form of energy called luminous energy, and it's also a form of wave. Light is visible to the sight. Plane surfaces. What's a plane surface? A plane surface is a flat, smooth, and reflective surface, which when light is incident on it, can reflect the light back into the same medium. It is not curved, it is flat in shape. Now, when you look at the plane mirror, which you can also say in terms of a plane surface, we have something which we call the normal. So let me add in this place, let me put mirrors here. So that you know we are talking about what mirrors. The plane mirror. Now the normal is an imaginary line that makes an angle of 90 degrees, that's perpendicular what angle, with the plane surface at the point where the ray of light is incident on the plane mirror, and that is what we call the point of incidence. Now you can see that this part here which I have here is looking shaded, which tells us that the plane mirror actually has just one reflecting part, the other part is coated. A very good example of it is your dressing mirror, which you use at home, the one you find in your barber's shop or your hairdressing salon. So this part, by the time I actually have a ray of light being incident on the plane mirror, this ray of light which is incident on the plane mirror is what we call the incident ray. Then when the ray of light is incident on the plane mirror, since it's a reflecting surface, it will go back into the medium. And that ray of light is what we call the reflected ray. Now there is an angle which we have between the incident ray and the normal. That angle is what we call the angle of incidence. Angle of incidence. Then the angle between the reflected ray and the normal is called the angle of reflection. Angle of reflection. Now there is an angle which we don't usually pay attention to. Many a times we pay attention to the angle of incidence and the angle of reflection. But there's an angle which we have between the incident ray and the plane surface of the mirror, and that angle is what we call the glancing angle. Glancing angle. Glancing angle. So with this defines the properties that we have in our plane mirror, and this has been able to give birth to what we call the laws of reflection. Laws of reflection. Laws of reflection. The first law of reflection states that the incident ray, the reflected ray, and the normal and the point of incidence all lie in the same plane. It states that the incident ray the reflected ray and the normal are the point of incidence. All lie in the same plane. Then the second one, which we have, the second law of reflection, states that the angle of incidence equals the angle of reflection. So that's it. So let's look at an example on the plane mirror based on the properties I have just explained, given us the laws. So an example is that a ray of light is incident at a glancing angle is incident at a glancing angle of 55 degrees. Calculate the angle between the incident ray and reflected ray on the plane mirror. So let's quickly look at this question. So a ray of light is incident at a glancing angle of 55 degrees. Calculate the angle between the incident ray and the reflected ray. Now remember from those properties of the plane mirror. Right, so let's take the solution. So the properties I actually give to you. So firstly, we draw our normal. Now we have our incident ray and we have our reflected ray. These are normal here. Now we are told that it was incident at a glancing angle. So you can see that that is not the incident ray. The glancing angle I've told us that is the angle between the incident ray and the plane surface of the mirror. So my glancing angle, I can call that G, could be 55 degrees. My angle of incidence, I can call that I, and the angle of reflection, I can call that R. So I need to get this angle and this angle because the question says calculate the angle between the incident ray and reflected ray. Let's add the ray and reflected ray of the plane mirror. So how do we go about this now? So if you see now, since we say the normal makes a perpendicular angle with the plane surface of the mirror. That tells us that both the angle of incidence plus the glancing angle will give what? 90 degree, which is it here. So that is the first thing you actually get from there. So that means that my angle I plus angle G is equals to 90 degree based on the normal. So that I can get my angle of incidence. So if I go to use 55 degree from here and I take it as my angle of incidence, and since we've said that the angle of incidence from the second law of reflection, that the angle of incidence equals the angle of reflection, if I say 55 degree plus 55 degree and I get 110 degree, I will miss the answer, because that is not the angle of incidence given to us, it was the glancing angle that was given. So from there, my glancing angle is 55 degrees, so I slot it in. I plus 55 degree equals 90 degree. So let's use here. So collecting like terms, my I becomes 90 degree minus 55 degree. So my I will become 35 degrees. So my angle of incidence now is 35 degree. Now from the second law of reflection, my angle of incidence equal angle of reflection, second law of reflection. So with that, definitely my reflected angle of reflection will also be what? 35 what? Degree. So since the question asks I calculate the angle between the incident ray and the reflected ray, I will add two together. So the angle of incidence plus angle of reflection, that will be 35 degree plus 35 degree, and that gives us what? 70 degree. That is the answer to the question. So thank you all viewers for staying with me, and I hope that time goes by. Thank you and do have a wonderful day.